So let's take a look at this example here. The question says solve matrix equation AX equals to B. Very good. So I have a 2 by 3 matrix. X is a 3 by 1 matrix. Since 3 and 3 are equal to each other, the resulting matrix is a 2 by 1 matrix, as you can see here. So AX equals to B. What do we have here? We have A, 1, 2, negative 2, 3, 1 and minus 2, x1, x2, x3, which is equal to B, 0 and 0. So what's the meaning of that? What is the augmented matrix that we can form here? This is our goal. What is the augmented matrix here? Okay, so let's do the multiplication. Here we have, let's see. So you get x1, and here you have minus, so you can convert this into a system of equations. As you know, x1 minus 2x2 plus x3 equal to 0, and this is 2x1 plus 3x2 minus 2x3 equal to 0. So the augmented matrix that you can form is 1, 2, negative 2, 3, and here you have 1, negative 2, as you can see, and you're going to add 0 and 0 down here. So I just wrote down the system of equations for you to remember that you can always convert this into a system of equations with two planes in this case. Plane 1, and this is the second plane. From calculus, you learn how to write the equation of planes. But this is the augmented matrix. You're going to take A, you're going to take B, and form the augmented matrix. So as you can remember, you're converting this into the form that you have 1, 0, then you have 1 and some numerical values, some real numbers. The very first element is 1, so we're good so far. But down here you have a 2, you don't have a 0. So what are we going to do? We're going to multiply the first row by negative 2 and add it to the second row. Negative 2 for negative 2, 0 plus the second row, which is 2, 3, negative 2, 0, which becomes 0, 7, negative 4, and 0. So your new second row is going to be 0, 7, negative 4, and 0. Well, we have to have 1 here instead of 7. So we're going to multiply the second row by 1 over 7. So this guy becomes 0, 1, negative 4 over 7. And then you have a 0, 1, negative 2, 1, and 0. Okay, our job is done. We can convert this back into a system of equations and start solving this, or converting this back. You have A, which is 1, negative 2, 0, 1, 1, negative 4 over 7. Your B stays the same. This is x1, x2, x3, and B stays the same, which is 0 and 0. Well, what does this system tells me? It tells me, hey, x1 minus 2x2 plus x3 is equal to 0. And it also says 0x1 plus 1x2 minus 4 over 7. x3 is 0. Okay, take a look at this. You have 3 variables. You need to assign a parameter to it. We need a parameter. Well, you might say that, hey, I'm going to, for example, take x sub 3 and call it t. I can take x1 and call it t, or I can take x2 and call it t. It doesn't matter which one you're using. So, for example, if I take x1 to be t, t is a real number, right? So since t is a real number, this guy becomes negative 2x2 plus x3 equals to negative t. And this is just x2 minus 4 over 7, x3 equal to 0. We have a relation between x2 and x3. You can write this as x2 equals to 4 over 7 x3. And then we can substitute this up here. You get negative 8 over 7 x3 plus x3 equals to negative t. And let's just continue. So you get negative x sub 3 divided by 7, negative t, or x3 becomes 7t. Since x3 is 70, we can just convert it that back x2 to be just 4t. So the solution that you're going to see is t. So you have infinitely many solutions because t belongs to R. And here you have 40. And then you have 7t. Infinitely many solutions.